Hello class. In this little mini lesson here we're going to talk about line loss and line drop and how it affects our circuits that we install within our buildings or houses or industrial establishments, things like that. So line loss and line drop are two components that we try to minimize. The reason for that is if we have too great of a line loss and a line drop in the circuit, it minimizes the efficiency of our load, or in other words, the voltage and the power output that that load is capable of having. All right, so if we analyze a very simple circuit here, and this circuit is a series circuit, which we're going to talk about shortly here. I'm going to draw resistances in series with the load. I'm going to call that like a motor or something. Okay. I'm going to connect this load up to a 120 volt source, and I'm going to have 1 ohm of resistance on my conductors. Okay, we could utilize that formula R is equal to K times L over CMA in order to come up with that resistance. Now I've just chosen an arbitrary resistance for some easy math, all right, so that we don't have to get our calculators out and get distracted by things. Now, if I told you that this load, when running, drew 10 amps, okay, our line drop is going to be based on the current flowing in the circuit multiplied by the resistance of those line conductors. Line drop is measured in volts, so that's your E is equal to I times R. So we'd go E, or our line drop, is equal to our 1 ohm times our 10 amps to give me a line drop in this case of something huge of 10 volts, okay? Now that is a one-way direction. We'd have to count the return, which would be a further 10 volts down here, all right? If we added those two together, we would see that we'd have 120 subtracting 10 volts of that first line, subtracting another 10 volts of that second line, and that'll give us a voltage out there at that load of 100 volts. Okay? I don't know about you, but your refrigerators and microwaves and televisions and computers would not like to be running at 100 volts. All right? They want to see their rated voltage, which is far greater than what that 100 volts would be. So those are situations where we have to pay attention and ensure that we install conductors here that are the right size, okay? In other words, large enough to handle the load that it's drawing. So, if I change, pardon me, if I change the resistance of these conductors to a greater size, what I will end up ultimately doing is giving me a better voltage out here at the load. I'm going to still continue with that 10 amps of current because the load hasn't changed, but I'm going to upsize my conductors to a gauge much greater, minimizing the resistance. So we'd have, let's say, 0.1 ohms here and 0.1 ohms there. Okay? So our line drop in this case is going to be the 0.1 ohms times the 10 amps, giving us 1 volt there and 1 volt down here. All right? 120 subtracting the 2 volts here will give me a voltage out there, the load, of 118 volts. That's far better than the 100 volts that we originally had. Now, something to keep in mind with these circuits is the Canadian Electrical Code mandates that we are not to exceed a 3% voltage drop in a circuit. So in this case, if we did the math of 120 volts times our 0.03 or 3%, okay, that'll come up with a voltage value here of 3.6 volts, okay? So we would not be allowed in this simple 120 volt circuit to exceed a voltage here of 1.8 volts there and 1.8 volts there. How did I get that? 3.6 divided by 2, okay, would give me 1.8 volts. Pretty straightforward there. So that's line drop. Line loss is measured in watts. So that is the wasted energy by the resistance and the current flowing in those conductors, okay? In this case, we could use two formulas. We could use P is equal to I squared R, or we could use P is equal to E times I, whichever you prefer. Ultimately, at the end of the day, we'd be looking at 1 volt times 10 amps to give me a line loss of 10 watts on that line and 10 watts on this line, giving me a total line loss of 20 watts. That's 20 watts of wasted energy that this load would not be capable of seeing, okay? Most of the line loss is going to be outputted in heat, so those are wires within your wall spaces that are heating up, doing nothing, okay? If they're pushed beyond what their ratings would be, that's when fires and things can occur. So we have to minimize the amount of line loss in order to maximize the efficiency out here, and also ensure that we are not paying BC Hydro for energy usage out here that is being wasted within the wall spaces. Okay, plain and simple, not too bad. We're going to explore some questions on your worksheets here shortly, and we'll get back to this soon. Next topic will be series circuits. Thanks.